So today we're looking at using exponential regression models. So our essential question is, how can we use exponential regression models to model data? So notice that I've included some links, which unfortunately you cannot access on paper, but I will be attaching a digital copy of this to the Google Classroom, so you'll be able to click on it there. But so if you do not have a graphing calculator, you will need to use 2 online calculators for this lesson. So a lot of you don't, actually all of you don't have a graphing calculator. So you'll need to look up this one. I'm going to copy that. Command C, Command V. Of course you cannot see. Oh, you can see it. There we go. So I got that thing going on. And then, no, you don't think you can see that. And then I'm also going to copy the Desmos calculator. So I need 2 calculators really to get this to work. Okay. So now that I just have my tabs open that I need to operate today, I'm going to go ahead and get started. So find the exponential regression function for the given data and use the model to make predictions. So the table shows the population Y of Lincoln City, where X is the number of years since the end of 2000. Suppose Lincoln City decides to build a new high school when its population exceeds 25,000. We want to know, when will the population exceed 25,000, which would be really cool if you think about it. Wouldn't it be nice to not be in the high school? Wouldn't it be nice to kind of just, I don't know, be in a middle school? That'd be cool. So we need to get the population to 20,000, 5,000. So in order to do that, I need to copy and paste this table. And step 1 is I'm going to insert it into this data table. So stat.blue, stats, suite, blah, blah, blah. It's that first link that I shared with you guys. So if I go over here, I don't know if you can see this. I hope you really can. I'm going to go ahead and insert my values into the column. So just kind of going back and forth. I have my years since, so 0, 1, 2, 3. So I'm going to enter those into the tables. Notice I'm putting them in as a column. Actually, it only goes to 7, so don't need all those numbers. And then I'm going to put my response. So my response is the population. I'm just kind of labeling my axes. And this one I have to be a little bit more deliberate. So I got 5,005, 6,010. And then I have 7,203, 8,700. And then I got 10, 5, 2, 1, 12, 4, 20. $14,982 and 18,010. Oh, sorry. If you guys are at school, then you know I'm not there, and it's because I'm sick. Apparently, I don't do well. So once I got it in, I just have to hit calculate. And look at that. I get this lovely curve. So that's pretty beautiful. And if you notice that on your notes, actually, that's the same curve that's been generated. So step 2 is that once I have this curve that's generated using this website, I'm going to take the equation that I was given. So notice how I was given this equation, y equals 5,011.4462 times 1.2006 to the x power, which means it's growing by 20% each year, right? I am going to go ahead and put it to the Desmos graphing calculator, and I'm going to estimate x at y is equal to 25,000. So I go ahead and I take that function. I'm just going to copy it and paste it. Oops, let's go to Desmos. I'm going to put y equals x. And then remember, since I want to know it when y is equal to 25,000, I'm also going to just go ahead and put that in there so then I can really look at the intersection of those 2 points, which is something that we looked at in module 5.1, I believe. So I'm obviously not zoomed in enough, so I'm going to zoom all the way out, find out where these two bad boys cross. So let's go ahead and just fix the axes. I'm really going to be looking at where an x is between, probably not in the thousands. So it looks at -10 to, let's go up to 50. That sounds like a good idea. And then on the y-axis, we'll go from 0 to 50,000. Or we'll do 40,000. I'm just doing that because it's going to give me a nice range to look at. So there we go. And look, if you look, it's right in the center there. And if I just click my dot on using the Desmos calculator, if I click right where those lines intersect, I get 8.791 and 25,000. So over here, that's about approximately 8.791. That's actually about approximately 9 years. So I'm just going to type in 9. So after 9 years, they will be able to build a new school. And that is how easy it is to use it. So again, if you don't have a Desmos, a graphing calculator, you do have to use 2 different resources. You're going to have to use this website, which unfortunately is going to be really hard for you to click on. So I do highly recommend at least just accessing these paper notes and putting them in. And then again, the Desmos scientific calculator, which you guys will